All right, welcome to the end of chapter 2. We've talked about a ton of these concepts, and today is all about reviewing everything we talked about in the chapter so we can be ready for our test that we're going to have tomorrow. So hopefully by the end of this process, we'll have refreshed and reviewed these things, feel confident about what we can do. You'll apply that in the study guide, come in tomorrow ready to do well on your exam. So we'll have 12 examples today, labeled 1 through 12. Make sure you have these notes down, and we'll turn in our notebooks at the conclusion of this lesson. So our first example, we remember we did one like this, where we're asked to translate a sentence into an equation. So this is how we started our chapter off, and we should feel pretty confident in how to solve these. So a number, x, just a variable. Subtracted signifies an operation. Which one is that? If you think about it, we know that means minus. So x subtracted from 36, is that 36 minus x, or is that x minus 36? Well, x is what's being subtracted. X is what's being taken away from the 36, which is our beginning number here. So it should be 36 minus x. That is x subtracted from 36. We see now is, that means equals 3 times what? It says the sum of. So 3 times two things being added together. And what are those two things? It's the sum of 4 and x. So there we go. 36, or x subtracted from 36, okay, is 3 times the sum of 4 and x. So 3 times, this is the sum of 4 and x. So there we go. So this is that expression translated into, or this is that sentence translated into an equation. Now we're not asked to solve it, even though we could. That's something we talked about later on in this chapter, but for this one example, all we have to do is turn that sentence into an equation. So you should be able to do that, an example just like this. So have this down in your notes for our first example today. Second example, number 2. Translate this equation into a sentence. So now we're going to work backwards the other way. So given the equation, let's write a sentence. So what's happening on the left? We see 3 times something. So I'll just put 3 times. Now it's 3 times what? Is it 3 times x? Is it 3 times y? Or is it 3 times the sum of x and y? Well, it should be the last one. It's 3 times both x and y being added together. So we should put 3 times, this is that key phrase, the sum of x and y is, I could say equals, but I'll say is 2 times y this should be jogging your memory, 2 times y, and then we'll say minus x. So have this down for example 2 for our review. Take that equation, write out the words in a sentence. Everyone's pretty good at this, so I feel confident in your ability to do that on our exam and in your study guide. Third example, we're asked to solve this equation. This is just one step. So what is the value of this variable given that equation? So what we would need to do to solve this here, we want r by itself. So this 12 is on the same side of the equation. We don't want it there. How do we get rid of a 12 that's tied by addition? Well, we do the opposite of add. We have to subtract. So if you subtract 12, forget that bar, subtract 12 from both sides, 12 minus 12 becomes 0. So on the left we get just r. And on the right, 3 minus 12 is what number? It is not negative 15. 3 minus 12 is a negative 9. So that has to be r in this equation. Just one step and you can solve it. You should feel confident about those one-step equations because we did a lot of those. And we also did multi-step, so we'll have some like that coming up. So this is it for the third example. So example number 4 asks us to solve a proportion. So we had some problems like this where we would write our two fractions. We would set them equal to each other. Once we set them equal to each other, and they say this is a proportion, that means this is a true statement, these two things are equal. How do we then go forth and solve it? Well, we have to say, we know they're equal, that means we can cross multiply. Find those cross products, and then set them equal and solve for our variable. So 9 times 125 will be equal to this 25p. Good, so we have that. We're halfway home solving this. Now that we have the cross products, all we have to do is simplify and we'll get that variable. So what's 9 times 125? 9 times 5 is 45. 9 times 2 is 18, plus 4 is 22. 9 times 1 is 9, plus 2 is 11. So we get 1,125 on our left side. On the right, we still have 25p. Now remembering that we need to get that p alone, we want just this variable. It's touching the 25. It's tied to 25 by multiplication. So how do we get rid of the 25? We do the opposite of multiplication. So we need to divide both sides by 25. So over here, this will cancel out. So we'll get just p. And it will be equal to 1,125 divided by 25. Now you can do that long division if you like and simplify that. Or you can plug it into a calculator. So if you do that, you should get p to be 45. So that's the value of that proportion when you solve it. This has to be the number that goes in the top right in our proportion. So we did some of those. Now say you have a problem like example 5. You're asked to find the value of this expression when the variables are equal to these numbers. So these evaluate problems, all you have to do, these are the easier version of the absolute value. Just plug in the numbers they give you and then simplify. So they tell me this is what we have. These are the absolute value bars. 4 times t plus n. T is negative 2, n is 5. So what do we get as a number? So absolute value of 4 times t, which is negative 2. 4 times negative 2 plus n. N is 5. Inside of the absolute value bars. What is this going to be equal to? Well, I know 4 times negative 2 is negative 8 plus 5. Negative 8 plus 5 is not 13. If you have negative 8 and you have 5 positives, you have 3 negatives left. It's negative 3. So this is our last step here. What is the absolute value of a negative 3? Well, remember these bars make everything in here turn out positive. So we make it positive, we remove the absolute value bars. So what is the solution to example 5? Just positive 3. Sixth example. So we have absolute value, but this time we need to solve for the value of the variable. Since we have to solve for it, absolute value could be positive or negative. what's inside of these bars. So in other words, the absolute value could be equal to 6 or negative 6. So we need to write both of those situations and solve for it. So we can remove the absolute value bars. We'll write the first case where what's inside is equal to a positive. That's the first case. And we'll write the second case where what's inside is equal to a negative 6. So the first case. Now we're back at solving two-step equations. So we can add 1 to both sides here, and 5t would equal 7, and t would equal 7 over 5. So that's one solution. Over here we could add 1 to both sides. 5t would equal negative 5. And divide both sides by 5 to get t alone. And t would equal negative 1. So those would be the two solutions there. So hopefully we're remembering that. The last thing it asks us is to plot them on a number line. So for that, on a test, you'll be given a number line. You can just plot those on there. So say this is 0. So negative 1 would be here. That's 1 point. 7/5 is a little bit more than 1. This is 1, and this is 2. 7/5 would be about there. And those would be our 2 points, and that is our solution to example 6. So a 7 type of thing you'll see. Here's another proportion, so we need to write that in the proper format. (18 over b). Good. Now we know to solve these, we need to go back and do that cross product. So we'll do 12 times b, 15 times 18. So we know we'll get this expression here when we do those cross products. 15 times 18 is going to give us a relatively big number. 8 times 5 is 40. 8 times 1 is 8, plus 4 is 12. 1 times 5 is 5. 1 times 1 is 1. 0, 7, 2. So 270. So 12b equals 270. We divide both sides by 12, and b will equal 270 over 12. Now is 270 over 12 a whole number? 12 goes into 27 twice, leaving me with 30 here. And 12 does not go into 30 evenly. So this is going to be a fraction. So let's just leave this as 270 over 12 for example 7. You could simplify that, but if you left it in this form, I would not mark it wrong. You could also write it as a decimal as well. So example 8. Now we see a variable on both sides, so we need to solve this thing. We can do it by combining like terms. Not too bad with just a few steps. So first, we'll distribute this 7 to everything here. We get that on the right. On the left, we get 5n plus 7. Now, 7n take away 2n is just 5n. So when simplified with just a step or two, you see we have the same thing on the left and the right. So what does that tell us? It's either going to be one of two things. all real numbers or no solution. So since this is the exact same thing on both sides, the value of n, well, could be anything. Anything would work. If we plugged in a 0, 7 equals 7, that's true. If we plugged in a 1, 12 equals 12, that's also true. So anything we plug in for n would be true. So the solution here is all real numbers. Done with that one. If we saw something that did not have the same thing on both sides, something like 12 equals 4, that has no solution, that is a lie, it's not a true statement. So for this one, that type of thing would be no solution. But for this one, all real numbers. Ninth type of example, finding the percent of change. So we talked about this a few sections ago. The percent of change is going to be the change over the original. And that will give us the percent change. So change over original, what are we going to get? So if we started at 55 and we ended at 44, you can think about what our change was. We started here, we went to 44, so we went down, so we know it's a decrease. We know it's a decrease. Went down 11, so it changed 11. Our original was 55. So the percent change would be 11 over 55. And if you do that in a calculator, 11 over 55 is about 0.2 as a decimal. 0.20 you could say, which if you rewrite that as a percentage is 20%. So our percent change, 20%. They'll also ask you in some questions, is it an increase or a decrease? That's easy, just say, did it go up or down? So it started here, went down, so it's a decrease, 20%. Now the 10th example for today, a shirt can cost $12. If the sales tax is 7%, what's the total cost? So how much is it actually going to cost you? So $12, sales tax is 7%. All we have to do is take that $12, multiply it by 7% as a decimal, which is 0.07, just move it over twice. So $12 times that is going to give me what is the sales tax plus my original $12 will tell me how much I have to pay. So 12 times 0.07 . 7 times 2 is 14. And here we get 8. So 84 with 2 zeros, 0.84. So 84 cents plus our $12. What's our total cost? $12.84. Pretty quick when you just add that sales tax on. So sales tax, your answer will always be above whatever you start with. If you have a coupon, then it should be below it by whatever value this is. Take your percentage, decimal, add it together, there you go. Okay, next one. A shirt costs $12. That's the problem we just did. So we're good on that one. So the 12th and final example for today. How many liters of a 90% acid solution, this is going to be a mixed problem, must be added to 6 liters of a 15% acid solution to obtain a 40% solution overall? So we did a problem just like this in our last section. So this is the chart we're going to need for this example. Make sure you have this down. We're starting with 90%. We're starting with 15%, excuse me. We're going to add some 90% solution. And we're going to end up with 40% concentration in the end. So these are the values we need to put in here. So first, we're given 6 liters of 15. We don't know how many liters of the 90 to add. That's what we need to find. So we'll add these together and mix them. So x plus 6 will be our solution. the acid amount. So how much acid is actually in each one? Take your decimal, 0.9 times how many liters? That gives you that. 0.15 times 6 here. And 0.4 times this whole thing there. So these would be the amounts of acid. So this plus this must equal our 40% solution amount of acid. That's how we get this equation here. That's how we generate that. So from here, now we're back to, can you solve an equation with the variable on both sides? So I could subtract that 0.4x from both sides. 0.4. So this would go away. Over here, I'd get 0.5x plus 0.9. So we have a 0.5x. We're adding this thing. We don't need that though. So we can subtract 0.9 from both sides. So if I bring this over here, we get 0.5x equals, we subtract 0.9, we get 1.5. And now the very last thing, we need to divide away this 0.5. So divide both sides by 0.5. And you can check this in a calculator. X will equal 3. So to answer the question, how many liters of the 90% do we need to add? We need to add 3 liters. And that is how you solve these problems. If you set it up in a table and use these amounts on the right, you will be golden with solving those problems. So with that in mind, we'll get practicing with our study guide so we can prep for tomorrow's exam.